This video is on function notation and relations. When we're doing function notation, we're going to tell which is the independent variable and which is dependent. Also, we'll be able to write a sentence given the relationship between the two variables using either depends on or is a function of, and we'll be able to write it in function notation. Our first example is weight and calories, which is independent, which is dependent, which depends on the other. We're going to assume weight is how much a person weighs and calories is how many calories they consume, they eat. So does how many calories somebody eats depend on how much they weigh? Or does how much they weigh depend on how many calories they eat? Now there can be an argument either way, but I feel one of these is better than the other. How much you weigh depends on how many calories you eat. If you eat 1,000 calories a day, you will lose weight. If you eat 5,000 calories a day, you will gain weight, no matter how much you exercise. So weight is a function of calories. How much you weigh is a function of how many calories you intake. How much you weigh depends on how many calories you intake. Your independent variable is calories. It doesn't depend on anything, it's independent. Your dependent variable is weight. Weight depends on how many calories you intake. Let's look at another one. Temperature and time of the day. Which is independent, temperature or time of the day? What depends on what? The time of the day is going to tick on. It doesn't matter if it's freezing outside or if it's 110 degrees outside, time of day is going to tick on. It's independent. But the temperature outside depends on the time of the day. The temperature outside is normally going to be the hottest right after lunch, and it's going to be coldest in the middle of the night. So temperature is a function of time of the day. The temperature depends on the time of the day. Time of the day is independent, temperature is dependent. Temperature depends on time of day or is a function of time of day. Area and diameter, which depends on which? Does the area of a circle depend on what its diameter is? Yes. The area of a circle is a function of diameter. Area depends on diameter. Diameter is independent, area is dependent. And some of these can be argued both ways. We're trying to do the best answer. All right, we're going to assume exercise is how much a person exercises, and weight is how much they weigh. In general, does a person's weight depend on how much they exercise, or does how much they exercise depend on how much they weigh? Okay, can be argued either way, yes, but the best answer I would say is weight is a function of exercise. How much you weigh depends on how much you exercise. Outside of the parentheses is the dependent variable, and inside parentheses is the independent variable. Exercise is independent, weight is dependent. Weight depends on how much you exercise. Weight is a function of how much you exercise. Electric bill and kilowatt hours. When you turn on the central air in your house, the little meter outside starts spinning, showing that you're using more and more kilowatt hours. And your electric bill depends on how many kilowatt hours you use. So your bill is a function of kilowatt hours. Okay. Your grades and hours of TV watched, or hours of video games played, or hours of time spent on social media, or hours of time spent on any device. Does your grade depends on how many hours you watch of TV or get on devices? Or does how much you watch TV and get on devices depend on your grades? Could be argued either way. Maybe your parents, if you have A's, let you watch TV and get on devices, and if you have C's and D's, they don't. So it could be argued that way. But I think the best answer is your grades depend on how much time you spend, maybe we'll call it wasting instead of studying. So grades is a function of hours of TV watched or video games played or anything like that. Amount of rainfall and river level. Does the river level depend on how much rain has fallen? Or does how much rain falls depend on the river level? Okay, the clouds don't look down and say, well, the river's low, we need to rain. The rain is going to come and go no matter what the river level is. But the river level will depend on how much it rains. So river level is a function of rainfall. Rainfall is independent. It's going to happen or not happen no matter what the river level. But the river level, whether it goes up or down, it's dependent on how much it rains. So river level is a function of rainfall. Length of the side of a square and perimeter of a square. The perimeter, how far it is all the way around it, depends on the length of each side. So perimeter is a function of side of a square. Side of a square is independent, perimeter is dependent. Number of lawns mowed and dollars earned. Try to write this one on your own in function notation. Okay, which is independent, which is dependent? What depends on what? It can be argued both ways, but the best answer, how many dollars you earn, depends on how many lawns you mow. Lawns mowed is independent, dollars earned is dependent. Money spent and number of CDs bought. Try that one in function notation. Does how much money you spend depend on how many CDs you buy? Yes. How much money you spend depends on the number of CDs you bought. The more CDs you bought, the more money you spent. So money spent is a function of number of CDs bought. If you'll notice, the independent variable always goes in parentheses in lowercase. The dependent variable always goes outside of parentheses, and it is uppercase. Money spent is a function of CDs bought, or money spent depends on CDs bought. CDs bought is independent, money spent is dependent. Try number 1, write it in function notation. All right, my independent variable is rainfall. The rain is going to fall whether or not there's already flowers on the ground. But the flowers on the ground depends on how much it rains. So we could say wildflowers depends on rainfall. Wildflowers is a function of rainfall. Try number 2. Number 2 can be argued either way, almost equally. But I think the best answer is available food supply depends on how many wild rabbits are eating it up. But it's almost as equally, and arguably more so, how many rabbits there are depends on how much food there is. Kind of disagree with that one. I like the first one best. I think the food supply is going to go down if there's more rabbits and go up if there's less rabbits. I don't think rabbits are necessarily going to die off if the food supply gets low, but that could be argued either way. This one could be argued either way as well, but I think there's the best answer. Try number 3. I believe the number of rabbits, and you can use whatever variable you want, is a function of how many predators there are. If there's a bunch of predators, wolves, coyotes, then there's going to be less rabbits. If there's less predators, there's going to be more rabbits. Try number 4. Amount of money spent and articles of clothing bought. How much money you spend depends on how many articles of clothing you buy. Number 5. Amount of stagnant water and number of mosquito larvae. How much mosquito larvae there is depends on how much stagnant water there is. If there's no stagnant water, Mosquitoes are not going to multiply. If you live around a swamp, there's going to be all kinds of mosquitoes multiplying in that stagnant water. And that is your introduction to function notation. And I said at the beginning we would do relations as well. I'm going to do that in a separate video. So this video is on function notation only.